Hello everyone, Maui again, and in today's video we're going to explain our second protocol, DNS, in details, and we're going to solve this room now in TryHackMe, learn how DNS works and how can it help you to access internet services. So let's get started. Starting with task 1, what is a DNS? A DNS, or a domain name system, provides a simple way for us to communicate with devices on the internet without remembering complex numbers. Much like every house has a unique address for sending mail directly to it, every computer on the internet has its own unique address to communicate with, which is called an IP address. An IP address looks like the following. So you have these numbers and they are grouped in 4 sets and they are ranging from 0 to 255 per set, separated by a period. When you want to visit a website, it's not exactly convenient to remember those complicated set of numbers, and that's where the DNS can help. So instead of remembering this IP address, you can just remember the word TryHackMe instead. So what does this mean? Basically, every device on the internet must have a unique IP address, and this IP address is just a geographical representation of its location. So if you live in Canada, you will have an IP address that represents your location in Canada. If I'm living in Qatar, or if I'm living in any other country, I will have an IP address that represents my location. Let's say through WhatsApp or any other application, I can have send and receive. So the sender will be my IP address and the receiver should be the receiver's IP address. And if we don't have any of these IPs, then we can't send the message. So this is what the DNS will help in. Currently, we can just try tryhackme.com and submit that in the URL, and we'll navigate to tryhackme.com without writing the IP address. So that's interesting. How does that work? This is the job of a DNS, or domain name system. It maps the word TryHackMe, which is easy to remember for us, and it maps it to its IP address of the server that's hosting TryHackMe. So remember in the HTTP protocol in details, when we explained that there is a header called the host header, and we said that when a server can host multiple websites, you must define the host with the name of the website. So this is the reason, because one server can have this IP, and let's say the host is serving all of these websites under it. So the host header will define which website you want to navigate to exactly. And we'll get in more details for DNS in the other task. So let's go to the question. What does DNS stand for? Let's join the room. And it stands for domain name system. Made a mistake here. And let's move to the second task, domain hierarchy. So what is a domain hierarchy? We have multiple types of domains, starting with the root domain. This root domain just maps us to the top level domains, and we'll explain what those means. Top level domain can be .edu, educational, .com, commercial, .gov, government, etc. And then we have what's called a second level domain, and these are the websites or the domain itself. MIT, TryHackMe, Google, USA, NASA, Army. You can have any other domain. So starting with the top level domain, or what's called TLD. A TLD is the most right hand part of the domain name. So for example, we'll continue with tryhackme.com as the example here. So tryhackme.com TLD is .com, as we can see. There are two types of TLDs. There is a GTLD and CCTLD. Ideally, GTLD is a generic top-level domain, just like .com, .gov, and CCTLD is the country code top-level domain, which represents a country. So starting with the GTLD, it was meant to tell the user the domain name's purpose. For example, if you have .com, it means that this is a commercial website. If you have a .gov, it means that this is governmental website, .org, organization, etc. And the CCTLD was used for a geographical purpose. So let's say .co means that, .ca means that you're based in Canada. .co.uk means that you're in United Kingdom, and so on and so forth. So you can have also a mix of both. So you can have, let's say, .edu, and then .ca means that it's educational website, but it's also under Canada. And for now, they're creating more of GTLDs, .online, .club, .website, etc. And you have the full list of over 2,000 TLDs here. You can just navigate to it and check if you want to. And this, let's continue with the second level domain, or what's called the domain name. Continuing with the TryHackMe, as we said, the TLD was .com, but now the second level domain is what's in the center of the domain name, which is TryHackMe. So .com is the top level domain, TryHackMe is the second level domain, or you can just remember it by saying this is the website's name, which is TryHackMe. When registering a domain name, the second level domain is limited to 63 characters plus the top level domain, and can only use A to Z, 0 to 9, and hyphens. Ideally, hyphens cannot start or end with hyphen, and you cannot have 2 consecutive hyphens. So now let's move to a subdomain. What is a subdomain? Subdomain sits on the left hand side of the second level domain. So you have TryHackMe in the middle, on its right you have the top level domain. If you have a subdomain, it will be before TryHackMe. So let's continue with this example. The name admin.tryhackme.com, as you can see, the word admin dot is the subdomain of TryHackMe. And when it comes to subdomains, you can have almost infinite number of subdomains, as much as you want, and the restrictions is the same when it comes to creating the subdomain, up to 63 characters containing A to Z, 0 to 9, and hyphens with the same restrictions. But you can have multiple subdomains split with periods, and this will create a longer number, and this can be up to 253, just like you see in this example, jupiter.servers.tryhackme.com. And as we said, there is no limit to the number of subdomains that you can create, and this is important when it comes to web hacking, and we'll get to it in the advanced module. So let's continue now with the questions. What is the maximum length of a subdomain? As we said before, it's 63. Which of the following characters cannot be used in a subdomain? And that should be the underscore. What is the maximum length of a domain name? That's 253, I believe. And lastly, what is the TLD of .co.uk? That's a CC, country code, and then top level domain. Alright, let's go to the third task. And now, as we said before, the DNS protocol resolves the IP address. So you can think of it as a table that has on the left side the IPs. On the right side it has the name of the website. So TryHackMe, on the right, on the left side you have an IP. Below it you have another website. On the left side it's IP address. So DNS doesn't only do that, it has multiple purposes. For each purpose it has a record, starting with the A record. These records resolve to IP version 4 addresses. For example, this IP will resolve to the domain name, which is TryHackMe. What A record, it does similar to A record, it just resolves for IP version 6 addresses. So you don't need to delve deep into this right now, just know that IP version 6 is similar to IP version 4, and it does exist in a network and is being used also. CNAME or canonical name, these records resolve to another domain name. For example, TryHackMe's online shop has a subdomain name store.tryhackme.com, which will retain a CNAME record shops.shopify.com. Another DNS request would be made to shop.shopify.com to work out the IP address. So yeah, okay, my mind's blown. This is complicated. What does it mean? So basically, let's say you're TryHackMe, or you're the owner of a TryHackMe, and you created a new subdomain that's called store. But this store that you created, the actual material of it is under shopify.com. So instead of putting this to the public, this is your subdomain, or this is your commercial material, you put it here in shops.shopify.com. You tell them that, hey, I have this subdomain which is familiar to your name, store.tryhackme.com, but when people navigate to this, instead of the DNS resolving the IP address of this store, it will actually say that, hey, this store.tryhackme is actually this, or links to this shop.shopify. So it will resolve a CNAME record, which on the left side you have the store.tryhackme, and on the right side you have shops.shopify. So it will take you there and then says what's the IP of this shops.shopify, and then resolve the IP of this and take you there. It's a little bit of redirecting about MX records. These records resolve the address of the servers that's handling the emails of the domain. So let's say for TryHackMe, they're having this domain that handles their mail servers, alt1.aspx.l.google.com, and it can has multiple MX record domains. So let's say 3. Each one will have a priority flag, which is a number, and the lower the number is, it means that the highest the priority is. So the domain with the lowest number will be the main domain of the mail servers that receives the mails for tryhackme.com domain, and then the second lowest will be used if the preferred domain is down for maintenance or any other reason. And finally, with the TXT records are free text fields where any text-based data can be stored. TXT records have multiple users, but some common ones can be lists the servers that the authority to send an email on behalf of the domain, and this can help against spamming and spoofed emails. This can also be used to verify the ownership of the domain name when signing up for third-party services. So let's continue with the questions. What type of record would be used to advise where to send email? That should be the MX record. What type of record handles IP version 6? That's the quad A record. And now let's see how DNS request works. So we've explained before how HTTP request goes and how it handles by the server. So now let's see how the DNS works. Basically, for a DNS, it's sort of a different type of requests, and you have 3 different scenarios when it comes to a DNS. So starting with scenario A, when you request a domain name, your computer first checks its local cache to see if you've previously looked up the address recently, and this is the first case. So let's stop here. You're trying to navigate to tryhackme.com, and let's say you've done that 5 minutes ago, and now you want to again visit tryhackme.com, and now your PC or your own cache on your device already have the IP address of tryhackme.com because it got it before. So it will just take it from your local cache, and then you can navigate to the website fast. But if not, and let's say this is the first time you move to tryhackme.com or you navigate to it, you will start with the second case. You will request it to your recursive DNS server that will be made, and this recursive DNS server is usually provided by your internet service provider or the ISP. A recursive DNS server is usually provided by your ISP, but you can also choose your own, so you can create your own recursive DNS server. Also has a local cache of recently looked up domain names. So basically this is used in your network, so it's not only you trying to resolve domain names to IPs. Let's say one of the other devices in your network has already navigated to tryhackme.com, and now once you reach the recursive, he will say, hey, I have the IP here, take it, and that's it. That's the end of the journey. But if the recursive one doesn't find it, and now you need to move to the third case. So let's see what the third case. We can continue from here. If the request cannot be found locally, a journey begins to find the correct answer. It's funny that they said the journey because it's a long journey, to be honest. Starting with the internet's root DNS servers. So now you'll move to the root DNS server, not you, your recursive DNS will request it. It will request that, hey, I don't have the IP of tryhackme.com, please can you help me? It will send it to the root DNS server. The root DNS server will say, hey, I don't have the IPs of any website, but I know that it's a .com, so I'll move you to the server that resolve .com servers. So the root DNS just move you to, let's move to that picture. It was here, easier to explain. So the root domain will say tryhackme.com falls under the .com domains, so he will send it to one of the servers that handles the .com domains, and the server will say that, okay, it's a .com, I can handle it, what's the domain name? It will say that it's a TryHackMe. The server will forward it to TryHackMe's authoritative server. And let's move down again. So what's an authoritative server? This server is the server that the DNS server for tryhackme.com domain, and it has all the IPs necessary for tryhackme.com's domain, so you can just ask it what's the IP, and now the authoritative will give you the IP and send it back to your recursive, which will save it in its own cache, and the recursive will send it back to you, which you can save in your local cache. And that's the whole journey that happens when it comes to sending it to the root or the third case. So we can just move down now. We've explained all of this, but one last thing is that DNS records all come with something that's called TTL, time to live value, and this value is a number represented in seconds that the response should be saved for locally until you have to look it up again. Caching saves on having to make DNS request every time you communicate with the server. So basically you don't just cache the IP address of TryHackMe forever, because they might change the, let's say, the domain name or their IP address for any reason, and so basically your DNS cache will just cache it for, let's say, 5 seconds and then remove it from the cache, and then whenever you want to navigate to TryHackMe, you have to make that whole journey again. So let's start with the questions. What field specifies how long a DNS record should be cached for? That's the time to live value. What type of a DNS server is usually provided by your ISP? That's called recursive. I think I said recursive before. I mean recursive. What type of server holds all the records for a domain? That's the authoritative. And now let's move to the practical. So in here we have 5 questions or 4. Using the website on the right, you can build a request to make a DNS query and view the result. The website will also show you the command you need to run on your own computer if you wish to make a request. So let's view the site. Scroll down, set OK. So we're giving with the command nslookup and then this website. So nslookup is a command that's used to get some DNS information about a target, and it's used for hacking also. So starting with the first question, we have here the DNS types, the 4 DNS types that we've talked about. What is the CNAME of shop.website.thm? So change the type to CNAME. You can see they added this command. The type is CNAME now, and here I only need to type the subdomain. So it's shop. Let's send the DNS request. We can see here the server, the address, and non-authoritative server answer, meaning that we didn't reach the authoritative server and we got it before. The shop.website.thm canonical name is this shops.myshops.com, myshopify.com. So let's copy it. Let's move to the next question. What is the value of the txt record on the website? So let's change this to a txt record. We don't need any subdomain. My apologies, the mouse lagged for some reason. Let's send. So here we have the txt value. If they don't stop you from doing that, you can get any information that's hosted on this txt. So let's copy, paste the flag. What's the numerical priority for the MX record? Remember that the lowest is the better, or the lowest value means that it will be selected as the main server. And here the value is 30. And with our last question, the type is A, so let's change. What is an IP address of a record of www.website.thm? Send the DNS request, and the address is 10.10.10.10. And with that, we finished the lab. Hope it was clear, and we will meet you again with the final lab when it comes to fundamentals. See you again.